Okay, so as I said, today we're going to start with factoring. And this is going to be a couple day progression. Okay. So there are quite a few different ways to factor. And we're going to talk through 1, 2, 3, 4. We're going to talk through 5 different ways on how to factor. Okay? The first way we're going to talk about is factoring by GCF, greatest common factor. It's the easiest way to factor. Okay? Hopefully we remember how to do that. The second type is binomial factors, which is difference of squares. And we'll talk about that. The third is if there are cubes. So we're going to talk through sum and difference of cubes. Okay? The fourth, and this is the one we'll spend the most time on, is trinomial factoring, where we'll talk through conventional method as well as AC method, which I think I showed you AC when we were going through the pretest, but we'll go through that again. And then the last way factor by group. Okay, so there are 5 different ways to factor. Okay. So we're going to start with the most universal of all of these, which is factoring by GCF. Okay, what does greatest common factor mean? Highest number and variable power that they have in common. So if we're talking about factoring by grouping, okay, we're talking about factoring by GCF. We're trying to find the highest number, variable, power combination we have. So let's start pretty simple. So if I want to try and start to solve this by grouping, or by GCF, I'm sorry, I don't know why I keep saying grouping. If I want to factor this by its GCF, 4x. So they both have a factor of 4, and they both have an x. Yes? Okay. Then I divide this by 4x. I divide this by 4x. 4x divided by 4x is just 16x to the 4th over 4x is 4x to the 3rd. Okay? And that, if all I asked you to do was factor by GCF, you'd be done. Right? If all I asked you to do was factor by GCF. Okay? Does that make sense? What we did there? We've done that before, yes?
Yes.
Okay. Okay. Find the GCF of that trinomial. Find the GCF of those three. What do they all have in common? Once you have an answer, do I need to move that up a little bit, or are we okay? Okay. Once you have an answer, compare with your table partners. $30 more seconds enough, or do we need more than that? All right. What's their GCF? What do they all three have in common? 4Z, right? Okay. But it wants us to factor by GCF. So I not only have to find the GCF, I then have to divide all three terms by 4Z. So if I do that, I have 2x squared y to the third minus 3x to the fourth z to the fifth plus 6y to the third z. How'd we do on that? Good? Okay. So are we good on GCF then?
Yes.
Okay. All right, binomial, difference of squares. So if we have a binomial, first off, what does a binomial mean? 2 terms. 2 terms. Okay, so there are 2 ways you can have a binomial. With addition and with subtraction. Okay? With addition and with subtraction. Now, can you have lead coefficients? Can you have numbers out front here? Yeah. But for the sake of what we're doing, not that big of a deal. So when you have a binomial, first thing you need to do every time factor out the GCF. Every time. Whether it's addition or subtraction, doesn't matter. Always find that GCF first. That's always step 1. Good so far? 2. Okay? This is going to sound really silly, but it makes a big difference. Is it plus or minus? Okay? Does anyone know why it matters if it's plus or minus? At that point. No? Okay. Reason this is important. If it's plus, So if it's x squared plus 4, and I ask you to factor it, you can't. Sum of squares does not factor. So if it's plus, and I ask you to factor it, you can't. All you can do is pull out a GCF. You may have been told that before. I'm going to show you why. Why that doesn't work. So, when you're factoring, what are you really finding? Zeros, right? You're finding where it crosses the x-axis. So if I set this equal to 0, how would I solve that? Subtract 4, right? So I get x squared equals negative 4. What'd you say? It's not possible, right? You can't. Well, you can, but what is that as an answer? Has I in the answer, right? What does I mean? Imaginary. So if we're trying to find an intercept, what does that mean? If the intercept is imaginary, there isn't one. So my graph never crosses the x-axis. So that is why sum of squares cannot be factored. Because if you have a sum of squares and you're factoring, it's never going to cross the axis. Because what shape is x squared? What shape's the graph? Come on, we talked about it. It's a parabola, right? It's a smiley face. Okay? And what does adding 4 at the end do? Moves the whole graph up 4. So it crossed one time at 0, 0. I moved it up 4. Well, now it's never going to cross. So that's why anytime you have a sum of squares, there's no factoring. And what do I mean by squares? Both the x and the number have a perfect square. So it could be, that could be 4, 1, 9, 16, 36, 25, 49, etc. We talked about all those numbers the other day, right? Okay. All right, so that was a long-winded way of saying if it's plus, you can't factor it. And I promise you, at least 4 of you will make that mistake on the factoring quiz. Okay? So try and help. Remember, if it's plus, you can't factor it. Or if you have to, try and solve it and think, okay, can I actually get answers or do I get I? Because if you get I, you can't factor it. Based on what you know. By the end of this year, you will be able to factor with I. But right now, you can't. Okay? So we talked about plus. We now need to talk about minus. And we call this, so if it's minus, we call that the difference of squares. And that actually has a very specific formula. And that formula is a squared minus b squared. Is this ringing a bell? And that formula is a minus b times a plus b. Which is how the conjugate formula works. Because the middle term cancels out. I need to move this. I'm sorry.
No, you're good.
Is that better?
Yeah.
A squared minus b squared is a minus b times a plus b. And again, this only works if both of these numbers or its sets are perfect squares. So that means this is x squared or x to the 4th or x to the 6th, anything divisible by 2, and this number by itself is a perfect square, like 1, 4, 9, 16, 25, etc. So, if I have x squared minus 4, and I want to factor that, what is my a going to be here? X. And what is b? Okay, so a squared is x squared. B squared is 4. So that means a by itself is just x. What's b by itself? What's the square root of 4? 2. So x squared minus 4 factors to x minus 2, x plus 2. X minus 2, x plus 2. Now, I'll also show you how that happens. I'll let you get this written down. Yep, if it asks you to factor it, that's all it wants. X minus 2, x plus 2. Questions so far? Good? Okay. So, reason that works. If I set this equal to 0, and I want to solve this for x, what do I do? Oh, did I go too fast?
No, you're correct.
What do I move? 4. Now what? Square root, both sides. But I drew the square root. So what do I have to put in front of my answer? We know. Say it louder.
Plus minus.
Plus and minus. Anytime you personally draw a square root in a problem, you have to put plus or minus in front of your answer. The reason for that is if I take 2 and square it, what's the answer? 4. If I take negative 2 and square it, what's the answer? 4. When you have even powers, you could have either a positive or a negative answer. Well, saying x is equal to plus and minus 2, that's the exact reason we have this formula. Because if I solve these out, what do I get for x? Plus and minus 2. Does that help that make sense a little bit?
Yeah.
Now, that's why, because what I'm afraid some of you are going to do is just do this. I see that all the time. I help people study for the ACT and they do this all the time. Because they love putting binomial problems like this where you have to know that formula on the ACT. So those of you that are taking the ACT this year, you're going to want to know your algebra formulas. So after we get through all this factoring, that's going to help you, hopefully, with the ACT. Do not do this. Either solve it this way or factor it this way.
You use that for every binomial.
Yes. Every binomial that can factor, because there are some that won't. So to give you another example, I gave you a very basic example to start. So to give you another example. Okay. We want to factor this. And this will be our last example for the day. First step is always what? Factor out GCF. What do these both have in common? 4. How did I get those numbers? Just divided both by 4, right? Okay. You're done with the 4 till the very end. So this is, again, one of those cases. You draw the arrow, leave it out front till right before your answer. Now what do I do with this? I use the formula, right? Difference of squares, yeah? So what's a squared minus b squared? A minus b, a plus b. So what's a here? Just a, not a squared. X. What's b? 3. B squared is 9, which then means b is 3. How do I get those numbers? Just take the square roots. Okay, plug into the formula. I get x minus 3, x plus 3, And there's my factor. That's it. Okay, so for tonight, you will not have any homework tonight besides looking over stuff for the quiz tomorrow. Yep. So the quiz tomorrow is again just over simplifying radicals. So taking higher order roots, conjugates, multiplying and dividing radicals.